All right, these are the answers to implicit differentiation worksheet, worksheet 2.5. So this one says find dy dx for this equation here. So we're going to take the derivative term by term for the first one. Derivative of negative 8x squared is just negative 16x. Then the next one we're going to treat as a product rule. We're going to have 5x times y. So the derivative of 5x is 5 times y as is, plus 5x times the derivative of y, which is dy dx. Okay. Then the derivative of y cubed will be 3y squared to start with, leave the inside alone, times the inside derivative dy dx, equals derivative of this, which is 0. All right. Now what we're going to do is we're going to move these two things over, and we're going to factor a dy dx out. So we're going to have dy dx times 5x plus 3y squared, okay? So that's pulling a dy dx out of those two terms, okay, equals, and if I add 16x over and I subtract 5y. So I'm moving the terms that have dy dx to one side, other terms over to the other. Then the last thing we do is divide, and we get dy dx equal to 16x minus 5y over 5x plus 3y squared. Okay. So that's our derivative. Now, part B says, what's the slope of the tangent line then at 4, negative 1? So the slope of the tangent at the point 4, negative 1 is equal to 16 times x, which is 4, minus 5 times 1, which is negative 1, over 5 times x, which is 4, plus 3 times y squared, which is negative 1 squared. All right, this is going to give me 64 plus 5, that's 69 on the top. 20 plus 3, that's 23 on the bottom. Divide that, we get 3 for our slope. Okay. So then part C says, can you write an equation for the tangent? Well, that's easy enough. Our point is that, and our slope we just found above to be 3. So y plus 1 equals 3 times x minus 4. Okay. Pretty easy there. Now this one says there's a number k so that the point this is on the curve. Using the tangent line, can we approximate that? We don't really want to go in and figure it out. For it, just can we use the tangent line to get a quick approximation? So in other words, 4.2 is in the x spot. Put that in the x spot here. We'll get y plus 1 equals 3 times 4.2 minus 4, which is 0.2. So now I get y equal to 0.6 minus 1, which is a negative 0.4. And that's the approximation of k for us. Right. So not too bad. Number 2, we have this curve here, and they want an equation of a tangent to the curve at x equal 3. And they said lines because there might be more than one y value. In fact, let's put 3 in for x and see what y equals. So we're going to get 9 plus 3y plus y squared equals 27. And if I subtract that, bring it over, I'm going to get y squared plus 3y minus 18 equals 0. And if we factor that, that's y plus 6, y minus 3, which gives us y equal to negative 6 or 3. Okay, so we actually have 2 points to consider, 3, negative 6, and 3, 3. All right, now, before we can make the equation, we got to find the slope at each of those points, and now we're going to do the derivative here. So the derivative of x squared is 2x. xy is going to be a product rule, so derivative of x is 1 times y as is, plus x times derivative of y, which is dy dx, plus derivative of y squared, 2y times dy dx, equals derivative of 27, which is 0. All right, so if we move these over, and factor, I'm going to get dy dx times x plus 2y equals negative 2x minus y. And so now I get dy dx equal to negative 2x minus y over x plus 2y. So that's our derivative. Now what I want to do is I want to see, well, what's the slope at each of these points? So we'll start with the first point, which is 3, negative 6. And if I were to put that in, I get negative 6 plus 6, which is 0, over 3 minus 12, which is, who cares, because 0 divided by anything is going to be 0. So our equation here, y plus 6 equals 0 times x minus 3, In other words, I'm going to get y equal to negative 6. So horizontal tangent at that point. Okay. For the other point, 3, 3, let's put that in and see what the slope of its tangent line is. So if I put that in, I get negative 6 minus 3, that's negative 9, over 3 plus 6, which is 9. I get a slope of negative 1. So y minus 3 equals negative 1 times x minus 3. That's that tangent. Right. So we were able to create two different tangent lines there for the two different points that were on that curve. Now, number 3 is worded really weirdly. It makes you feel like you have a lot of work to do, when in actuality, it's giving you most of the information here. It says, let f be a function so that f of 1 equals 4. Right away, when it says f of 1 equals 4, that means the point 1, 4 is on that curve. Okay? And such that for all points on the graph of f, the slope is given by this. Well, if that's the slope of the tangent is given by this, that means that this is the derivative. What they're telling you is dy dx is equal to 3x squared plus 1 over 2y. Right? Now, they didn't say that, but that's what they gave us. So when it says find the slope of the graph of f at the point where x equals 1, when x equals 1, y equals 4, they want you to put that point in here and see. So dy dx is equal to 3 times 1 squared, that's 3, plus 1 is 4, over 2 times 4, which is 8, we get a 1/2. That's the slope at that point. So then when we get to b and it says write an equation for the tangent line at 1, we already have our point. That was 1, 4. We have our slope now of 1/2. So y minus 4 equals 1/2 times x minus 1. And if we want to approximate f of 1.2, that means we're going to put 1.2 in for x. It gives us y minus 4 equals 1/2 times 1.2 minus 1, which is 0.2. Half of 0.2 is 0.1. So if you add 4 to that, we're going to get y equal to 4.1. There's our approximation.